Okay, good morning, everyone. I'm Chiru Yo from National Taiwan Ocean University. It's happy to meet you guys online today, and it's really thanks ICAF for inviting me to share my research with you guys. Today's talk is based on the paper I published in 2021 and updated some data. So the topic of today, I just made the distribution of Megamouth shark in the three ocean. Megamouth is a very rare and special species. The first Megamouth shark, Megachasma pelagios, was found in Hawaii in 1976. It's a male in 446 centimeter in total length and 750 kilograms. Until now, already over 45 years, the information of this species is still unclear. And Megamouse is a placental viviparous species and usually filtering feed on planktonous prey. And the max size of Megamouse should be like around 7 meter in total length. Although there are many public resources for recording the Megamouth shark, they are still very scattered, uncompleted. When checked the literature review, we found most of the record were single individual record, and little is known about the biological information. When we talk about multiple individuals, there were only few papers. The first one from Nakaya 2010 provides some biological information of 40 individuals. Another one was from Liu et al. 2018, including 99 individuals. But Lee's study was for genetic research without any further elaboration. And the one in 2019 recorded 170 individuals. However, our research team used to report there were still many records need to be updated in 2018. And if you notice here, we had more individual than 2019 one. So why we have so many records? Actually, the reason is because one special mechanism from Taiwan. Taiwanese Fishery Agency has a mandatory catch and report system for megamouth shark since 2013, and soon there was a ban fishing since 2020. And between this period, our fishers have to make contact with fishery agency right after they catch the shark. So let me introduce you the large mesh drift net first. This is the fishery by catching megamouth shark and always operates in the eastern Taiwan water and targeting the sunfish, which caught mola mola during April to August. It usually operates from sea surface to 100-meter deep and works in the evening. And sometimes it will by catching megamouth shark. So if fisher catch the mega mouse, they have to follow the catch and report system to make contact with Coast Guard, fisher agency, and shark researchers. When the vessel arrived at port and tried to landing, the observer will help the fisher with recording the capture information, including the body length, weight, sex, location, target species, etc. So now let's back to previous study. In fact, previous study mentioned couple problem need to be figured out. The fuse basement problem, the lacking smaller size individual problem, and some mature and mature individual were few in lower latitude from April to October, and there is not enough data for vertical distribution. Therefore, the aims of this study were to integrate the record of Megamouth shark and to provide supplemental information to previous study, especially on the distribution of these species. So I try to collect the data of Megamouth shark as detailed as possible from different places and resources such as the reference, online information, news, SNS resources, NGO, government authorities such as NOAA Fishery, and even some information from our shark friends. On the other hand, the Taiwan part, we mentioned before, the catch and report system helps a lot. And if the situation is okay, we will measure different standard of the shark and different body part of the shark were measured for further conversion equation establishing. So according to our data collection, we made several relation in conversion equation among different body parts such as the mouse wide, dorsal fin, pectoral fin, and caudal fin length. Although some equation shows lower R square value or non-significant relation, we still provide this this equation as the reference. Then, before we combine and compare report, we have to make sure the population structure first. In 2018, we cooperated with a research team from National Sun Yat-sen University for testing the genetic structure of leaf species from different water. And the results indicate that there is no genetic structure of Megamouth shark from different places in the Pacific Ocean. So we integrate the data into the same standard. For example, we transfer the pre-caudal lens or fork lens into the total lens. Then, after remove the uncertain data, this study made lens weight relationship from 93 females and 58 males, and you can find the difference between male and females. One convincing reason is because Megamouth is a placentoviviparous species, which may have like a well-developed but very few number large embryos, and the ovary and uterus of female may become very heavy and big when they become mature, and leading to the difference. So, how about world record data from 1976 to 2020? There were 264 individuals be exempt in this study, 134 females and 87 males, and 43 sexual unknown individuals. Most of the female were 3 to 6 meters, and for males were 3 to 5 meter. Female is larger than male, and the results are similar to many shark species, such as the shortfin mackerel or the whale shark. And the possible reason for this is that female needs more space in the belly to carry their baby. So let's move to horizontal distribution now. This figure shows that the megamouse is worldwide distributed, but you can see the hotspot is around northwestern Pacific. So we separated here our water into four groups: the India, Atlantic, and because the Pacific Ocean is quite wide, so we make it as Western and Eastern Pacific Ocean. And let's start from the simple part. In India and Atlantic waters, there were more small sharks in these two oceans, and also the individual bigger than 4 meters. But we lack the middle-sized individual here. That is to say, there is a high possibility that India and Atlantic Ocean is the nursery area of Megamouth shark. And when we check the Pacific Ocean, There were 214 megamouths being recorded in the western side. And you see the ratio of female was more and focused on 4 to 6 meter, that is maturing and mature stage. And when we look the eastern sides, the fewer females but larger males here. And this should be an evidence for sexual segregation, which is common on large shark species such as the great white shark. On the other hand, the smaller than 3-meter individual was little in the Pacific Ocean, leading to the high probability of foraging, growth, and mating in this area. So, most of magmouse were found in northwestern Pacific. We separated this area into 3 regions by latitude in each 15 degrees. So you can see area one, range of size from 2 to 6. The under 3-meter individual were half of them smaller than 2.5. But when we look the region 2, few individuals smaller than 2.5 meter, and this area was the mainly record area for megamouth shark. Then when we check the area 3, no individuals smaller than 3 meter, and the ratio of larger than 4-meter shark was higher, and most of them were females. You can see the ratio female increase through the latitude increase. So in 2018, Dr. Naka had the public Megamouth shark anatomy exhibition, and that was the first time to find the a capsule in the uterus. These may infer that high latitude water in northwestern Pacific Ocean is a habitat for mature female. So, further, we curious that whether time affect the distribution of Megamouth shark or not. But before that, we try to figure out the maturity stage first by observing the developing stage of some reproductive organs. According to observation, we try to separate megamouse into mature, submature, and mature stage for further analysis. And the out of Taiwan record individual word note based on the description of other resources. So, figure 6 shows megamouth sharks distribution in different months. You can see all of the immature individuals were recorded at lower than 30 degree, but mature individual can move to higher latitude area. That is to say, mature megamouths may have the ability to tolerate higher latitude and cold waters. And actually, this figure includes many sex or maturity unknown records. What's more, few records were found Indonesia and in India and Atlantic Ocean. And actually, we cannot make any statement for them. So after we make the figure simpler, figure 7, it's only for female and male from Pacific Ocean. When we start from the females, so from January to March, they were scattered, appeared in the waters in the western side. And during April to August, there were mainly in the middle latitude water. And after September, only be recorded in the higher latitude water. And again, very little in no, in October and November. So the tendency is more like the female try to move to middle and higher latitude water from March. On the other hand, the males during January to March only one record from high latitude. Others were all from lower latitude and from western or eastern Pacific. Then a lot records from middle latitude between April and August. Then one time, went to October, some mature males appear in the eastern Pacific water. As aforesaid, there was an evidence to infer the sexual segregation in Megamouth shark, and here we found it. It could happen after summer. Most of the male are, and very few females may move to eastern side. All right, so let's move to vertical distribution. The depth data include the reliable catch depths or operation depths from fishermen and observers of Noah fishery. So figure 8 is capture depths of megamouth shark in different size. As megamouth shark grows, it seems that they have the ability to move deeper, and mature female were recorded much more in different depths. But one male was found in 800 meters. According to this, mature megamouths may tolerate the deep water, which is a higher stress and lower temperature. Previous studies said that many laminated sharks, such as trophy mackerel and thresher shark, have some capability of endothermic regulation. They could conserve heat and arrange their body temperature well to against lower temperature. Further, we try to analyze the deep distribution in different time. There were 23 reports, and most of them were caught from 0 to 6 a.m. And the depth was increased through the time. The data were from our fishers or NOAA fishery, and one was sighted at the sea surface at 11 a.m. This individual was attacked by the whale. And again, others around 10 p.m. came to shallow water. Actually, Nielsen et al. In 1997 shows acoustic track resort and pointed out that Megamouth shark has vertical migration, and this behavior is related to light. And our research are very similar to Nielsen 1. And most of our record were from DriftNet by catch, which is very convincing because the feature will count the mesh number and try to calculate the depth for us. So, to sum up my study, megamouths mainly inhabit in the Pacific Ocean. Our results show female is larger, and the large individual may have the ability to arrange their body temperature so they can dive deeper and move to higher latitude area. Spatial temporal sexual bias and potential nursery area were found in this study. And according to these results, a hypothesis was made. Megamouth shark give birth in the eastern Indian Ocean near the Philippines and Indonesia. During growth, they move northward to the western Pacific Ocean and arrive in Taiwanese water in April, forage and grows here until August. Some mature female, which can withstand cool temperature, they will keep swimming up with the crucial current, arrive Japanese water in the spring. Then in the late summertime, females stayed around Japan, and the males move across the Pacific Ocean toward the eastern side by following the North Pacific Current. Then the males arrive California water in late summer or autumn, then move southern to Mexico and Peru. Afterward, some mammals will move across the Pacific Ocean again toward the western side, thereby returning to Indonesia or Philippine water. However, this is based on the single genetic structure and spatial temporal sexual bias in our data, according to the theory of migration or movement, usually based on the strong purpose such as feeding, mating, and breeding. But for megamouse, there is still many mysterious, like how about the motivation for moving or the mating area, and how about a pregnant female? Since Taiwan already banned the megamouth shark fishing, biological data collection will be very, very challenging. So further study we think should use like the satellite tracking or international data exchange, then could be possible way for proving our hypothesis and better understanding of these species. And this is my presentation. Thank you for listening. Now we are open for questions.